In the last video, chapter 8.8, factor by grouping, we factored a quadratic trinomial that we split the middle term of, and then we had this 4-term polynomial that we factored the first 2 terms, factored the second 2 terms, and wound up with the greatest common factor. Now, another place you need to factor by grouping is when you actually start off with a 4-term polynomial. So we started off with a 3-term polynomial, but created a 4th term. Here, we're actually starting off with a 4-term polynomial that can't be simplified any further. It's a 4-term cubic. So we have 3n to the third minus 12n squared plus 2n minus 1, or minus 8. So here again, just like we did up here, we're going to factor the first group, and we're going to factor the second group. We're going to separate this 4-term polynomial into 2 parts. Now, the greatest, and make sure that you take a GCF out first. So, is there a GCF? No, there's a 3 and a 2 here, so there's no GCF, and there's no n term in the last digit, so we don't have to worry about the n's. We're in good shape. So GCF checks. All right, biggest thing we can take out of the first 2 terms. The greatest common factor here is going to be 3n squared. And 3n squared times n minus 4 is going to be back to our original statement there. And then our last section, we have 2n minus 8. Biggest thing we can take out there is a 2. So I'm going to take out plus 2. And then this is n minus 4. Now, once again, just like up here, we had a greatest common factor in these 2 terms with the x minus 5 and x minus 5. Here we have the n minus 4. So here's your greatest common factor of these 2 terms, this term and this term. All right, so in each of those cases, we are going to take the n minus 4 out. So n minus 4 times 3n squared plus 2 is our factored form. Now, a couple of things to be careful of. One is this greatest common factor at the beginning. That's super important, greatest common factor at the beginning. The second thing is, notice that one of these terms is still squared. Now, that means that sometimes if you take a cubic and you factor out a linear binomial, you wind up with a quadratic. If you take a cubic, let's hear that again, if you take a cubic, 3 power of 3 statement, and you factor out a linear binomial, you take a cubic and factor out a linear, you wind up getting a quadratic. It's not impossible that you get a quadratic over here that you might be able to factor further. Let's say this was n squared minus 9. It's possible if you had n squared minus 9 that you can factor it, right? Because it's a difference of squares. But 3n squared plus 2 doesn't factor any further. There's no greatest common factor. There's nothing else to do with it. But be careful that maybe this one of these factors is not factored fully. Is this fully factored? All right, so that's important. All right, now I have 2 other examples for you that I'm not going to do, but I'm going to ask you to do. So these are the 2 other examples. You can write these down, pause the video and write these down. In both of these cases, you have a greatest common factor to start off with. All right, notice you have a Q as a greatest common factor as well as a numeric greatest common factor of 4. And here you just have a numeric common factor. So take those greatest common factors out first, and then factor the first 2, factor the second 2. Take the once you get the greatest common factor out, and then make sure that you factored fully after you do the factor by grouping routine. Okay. Hope that helps. I'll see you tomorrow in class.